Okay, in this lesson, what we're going to be doing is looking at the trigonometric ratios of quadrantal angles. Now, those are the angles that are in between the quadrants, so 0 degrees, 90 degrees, 180, and 270. So those angles, as you know, are like between quadrants 1 and 2, 2 and 3, 3 and 4, and 4 and 1. So to determine the trig ratios of the quadrantal angles, what we're going to recall is from a previous lesson, and I'm just going to show you that lesson right now. This lesson right here, what we learned in all of these cases when we came up with these ratios is that sine is always the ratio of the y-coordinate over r, and r was the distance from the origin to the point. Cos was the x-coordinate over r, and tan was the y over the x-coordinate. Regardless of the quadrant that you're in, that is the case. It's just that they differ in the second quadrant, for example, because the x-coordinate would be negative. But essentially, sine is always y over r, cos is x over r, and tan is y over x, and r is always the positive distance between the origin and that point. So if we remember that, it's going to be really, really helpful here. So we're going to recall the following. We're going to recall that sine is always the y-coordinate over r, cos is the x-coordinate over r, and tan is the y-coordinate over the x-coordinate. And you just have to recall that r is the distance from the origin. Okay? So to make quadrantal angles simpler for you to recall and understand, what we're going to do is use an r value, or the radius, when we look at it in the future, the r value equal to 1. If r was equal to 1, what you're going to see is that both of these, both of these r's will be inconsequential, okay? Because they're equal to 1. So in that case, the sine ratio would be equivalent just to the y-coordinate, the cos ratio would just be equal to the x-coordinate, and tan would still be the y-coordinate over the x-coordinate. So let's go ahead and look at these different quadrantal angles, so 0, 90, 180, and 270, and you should be able to memorize these ratios, and you can always check it on your calculator if you'd like to at any point in time, but they will ring true. So first of all, the sine of 0 degrees. So if we took a distance from the origin to a point on the x-axis, and again, we knew that that distance was 1, so that's going to be inconsequential. We know that the point here would be the coordinate 1, 0. Okay, so essentially, really easily, we know that sine is equal to the y-coordinate, which is 0. We know that cos is equal to the x-coordinate, which is 1, and we know that tan is equal to the y over the x-coordinate, which is 0 over 1, which is equivalent to 0. And you can always do those right on your calculator. Just put in sine 0. Make sure you're in degree mode. I don't have a calculator shown on my screen, but those would be the ratios of those angles, okay? So next. So kind of cool that you can actually know these just from those ratios. Next, if we have a 90-degree angle, if we took a distance from that origin to a point, a distance of 1, so it's going to be inconsequential, but if that is a distance of 1, we know the x-coordinate is 0 and the y-coordinate would be 1, okay? And since sine is equal to the y-coordinate, it's equal to 1, cos is the x-coordinate, and tan is y over x, which is 1 over 0. Now, what we do know about mathematics, you can try this on your calculator, is anything divided by 0 does not exist, okay? So you will get an error on your calculator, a divide by 0 error, if you try and do the tan of 90, and you can try that on your calculator, just do tan 90 and hit equals. All right, the next angle, which is 180 degrees, if we take, again, a distance from the origin to a point on the negative y or negative x-axis of 1, we know that coordinate would be negative 1 and 0. That would mean that the ratios for those angles would be 0 for sine, negative 1 for cos, and 0 over negative 1, or in other words, 0 for tan. Okay, and the last ratio, or the last quadrantal angle that we're going to calculate here, so this will always ring true for these quadrantal angles, is 270 degrees. So if we had a distance from the origin to a point on the quadrantal angle at 270, the x-coordinate in that case would be 0, and the y-coordinate would be negative 1. Okay, so if we go ahead and figure out the ratios for that, sine would be negative 1, cos would be 0, and Negative 1 over 0 or y over x does not exist. Okay, so those are the quadrantal angles. You'll have to have those memorized, those ratios memorized. But again, the easiest way to do it is just using the steps or kind of the key ideas that I have listed here. So you theoretically shouldn't have to memorize them as long as you use those ratios and remember those. So in an extension to that, something that you might learn in the future, it might not be in the current course that you're in, but I just want to show you is actually we can extend that to all of the angles and kind of come up with an approximate ratio for all of the angles using what we call the unit circle. So kind of out of interest's sake here, if we used a unit circle, so again, the easiest base number is 1. So if we took a circle here and its radius was 1. So no matter where you go from the origin to a point on the circle, we always have that radius is equal to 1. The nice thing about that is that we just learned, so if we consider a circle with radius 1, meaning that sine is equal to the y-coordinate and cos is equal to the x-coordinate, we can approximate all of the trig ratios for the angles between 0 and 360. So see if you can follow me here, but let's kind of give you an idea of what this would be. So I'll just use my green pen for the sine, what we call the sine curve. So we learned that if we have a 0-degree angle right here, we know that the y-coordinate is 0. So we know that at 0 degrees, the sine ratio is 0. Okay, and we know and you can even ask yourself, and I can ask you the question right now, is as we go to 90 degrees, so we start rotating counterclockwise, what happens to the y-coordinate? And you'd say, oh, the y-coordinate actually, as I follow this path up, it increases until it hits 1 at 90 degrees. So what actually happens here to what we call the sine curve is between 0 and 90, this ratio keeps increasing until 90 degrees it hits a ratio of 1. Then you can do the same thing. If you keep increasing that to 180 degrees, you would now have a y-coordinate that goes back down to 0. So the y-coordinate keeps decreasing. At 180 degrees, it goes back down to 0. And if we go to 270, you'll see if I just keep following that path, the y-coordinate from 180 degrees down to 270, just the y-coordinate, would eventually fall out at a minimum of -1 at 270 degrees. And if you follow that logic all the way back, it would then at 360 degrees come back up to 0. This is actually called the sine curve, and it actually kind of approximates the sine ratio for all angles. So we know that the sine ratio at 90 degrees is 1, at 180 is 0, at 270 is -1, and at 360 is 0. That's kind of cool. So that's your sine curve. So you might want to predict, you could pause this video if you'd like to, but you might want to predict what the cosine curve might look like. So the cosine curve is always equal to the x-coordinate. So if we look at that, the x-coordinate of 0 degrees is 1. So we know that at 0 degrees, we've got a coordinate, an x-coordinate of 1. And now ask yourself, what happens to the x-coordinate now when I get to 90 degrees? And you'd say, oh, the x-coordinate used to be 1, and it's getting smaller and smaller and smaller until at 90 degrees it hits 0. So what happens to the cos curve there is it kind of goes smaller and smaller until at 90 degrees it hits 0. What happens to the x-coordinate as we approach 180 degrees? Well, it becomes smaller and smaller until it hits a minimum of -1. Okay, and that would be right here. Okay, and then what happens to the x-coordinate as we approach 270 is that it would go from -1 and start increasing to 0 at 270. Whoops. So this would happen here. And then again, as it goes back up to 360 degrees, you would notice that the x-coordinate gets larger until it hits a maximum of 1. And that shouldn't technically surprise you. So these are actually an introduction to what you're going to be learning in future math as well. But these are called the sine and the cosine waves, and they approximate all of the sine and cosine ratios between 0 and 360. And you can see the exact values for 0, 90, 180, 270, and 360, which we refer to again as the quadrantal angles.